All right, last section here. A car driving towards a mountain sees the peak at an angle of 8. So here's our cheesy mountain. Here's our flat plane. Here's our car looking up at the top of that. That's 8 degrees. It drives 5 miles, right, to a new spot. So right here it looks up, and now that is an angle of 15 degrees. So the question is, how tall is that mountain? What is that height right there? Well, you can really do this a couple of different ways. I think that the simplest way, maybe just for our purposes here, is to figure out what the length of this unknown diagonal is, x. Because if I can solve for that, then I've got a smaller triangle with 15 and x and h. Once I have that as a number, I can solve it. So what is the triangle that will get me this solution here? If I were to re-sketch it and exaggerate the angles a little bit, this is angle 8, this is 15, so this is 165. If I do the math, then this is 7 degrees here, and so now I can use the the law of, that's 5, I can do the law of sines twice. So the sine of 7 degrees over 5 miles, so there's the 7 degree angle right there, over its opposite side, is equal to x is in the denominator here, and its opposite is the sine of 8 degrees. Okay, if you do that, then we can just crunch those numbers. Sine of 7 divided by 5, and then I'm going to say the sine of 8 degrees divided by that answer up above, 0.02437, and I get 5.7 miles, 5.71 miles. So x equals 5.71 miles. Well, I now know that there's my opposite, that's h, so again it's the sine, so I can write the sine of 15 degrees is equal to h over 5.71. So this times the sine of 15 degrees is going to be my answer, 1.47 miles. So how far above the driver's elevation to the top of the mountain? The answer is 1.47 miles. If you want to get some extra credit, multiply that by 5,280 feet, and you can tell me, because 7,800 feet, so about 7,800 feet. Okay, so try that when you're in the mountains sometime, calculating the height. Okay, so I've got these straightforward equations. There is a typo here. This is clearly over 3 up 5. I'm going to write that larger. This is over 5 down 3. This one is over 1 up 5. I'm sorry, I was born dyslexic, and I'm going to stay that way. Over 1 up 5, and this is 2 negative 1. Alright, so I think we're good. This is a parabola. Parent function y equals x squared is translated by this vector over 3 up 5, so it's y equals x minus 3 squared plus 5. I've got this other point to contend with. That's going to tell me my a value that I'll fill in there. So I'm going to put in negative 3 comma equals a times 5 minus 3 squared plus 5. Well, 5 minus 3 is 2. 2 squared is 4. So 4a, if I take away 5 from both sides, is negative 8. Divide by 4, it's negative 2. So negative 2. I just left that in there so I could fill it in and write the answer. Correcting for this now, the parent function is y equals the absolute value of x. I'm translating this over 1 up 5, so y equals x minus 1, absolute value, plus 5. Again, there's an a out front that gets you down to this point down here. Negative 1 then is equal to a times the absolute value of 2 minus 1 plus 5. Well, 2 minus 1 is 1. The absolute value of that is just 1. So that's going to be a, and if I take away 5 from both sides, I'll get negative 6. When I plug in negative 6 right there, I get my answer. hopefully that's quite straightforward. Next one, it's a square root function. So y equals the square root of x is what we're going to start with. It helps to kind of think about what that's going to look like. This is a flip this way and then a flip down. So it's been flipped in both directions. So y equals negative square root of negative and then x. I think it helps to bring the negative outside and then do your translation of this and the modification. Well, it's been moved over 1 and up 2, so it's going to be y equals negative and then negative x minus 1, we'll move it over 1, and then tack on the plus 2 at the end there. And then it's being stretched, so there's an a value there that I'll find, and it's going to give me this negative 3, negative 2. So I'm going to put negative 2 equals, and then negative a times the square root of negative 3 minus 1 is negative 4. Negative 4 is positive 4. When I take the square root of positive 4, it's going to be 2. So I've got this plus 2. When I take that away from both sides, I'll get negative 4 equals negative 4a. Well, a is just 1 then. That worked out kind of nicely. Nope, I did something wrong. If I take away, take away 2. Okay. Something looks fishy about that. But there we go. It's just negative 1. So y equals negative radical negative x minus 1 plus 2. All right? Very good. This one then is a cubic, y equals x to the 3. I'm shifting this back 1 and up 2. So it's y equals x plus 1 to the 3rd plus 2. And there's going to be an a that will get me to this point, 1, 6. 6 equals a times x, 1 plus 1 cubed plus 2. Well, 1 plus 1 is 2, cubed is 8. If I take away 2 from both sides, I get 4 equals 8a, so 1/2 equals a. So my best final answer is y equals 1/2 x plus 1 plus 2. Lots of plus 2's going on there, but that is it. Finally, sketch the graph of this one. Exponential. We're just going to label this. Your original exponential hugs this horizontal asymptote. Asymptote scoots way steeply, gives you the point 0, 1 and 1, 10. My translation vector is back A and down B. So I'm just going to take these 2 points and do that. If I'm going back A, well actually it's just going to be moved. Down B, so my asymptote here was y equals 0, but it's now y equals negative b, and then back a amount and down b amount is going to give me a point right here that is minus a, 1 minus b. Yep. And then I'm going to zoom upwards, and this point is going to be 1 minus a, and then 10 minus b, because that value there is being shifted downwards by b amount. And we are done. Good luck.